Mars, the red planet, a world that has long fascinated scientists, astronomers, and dreamers alike, a celestial neighbor that has captivated humanity for millennia. Its presence in our night sky has inspired countless myths, legends, and scientific inquiries. Its rusty hue, visible even to the naked eye, sparked tales of war and fury in ancient cultures. The Romans named it after their god of war, Mars, while the Greeks called it Ares. This fiery appearance has always been a symbol of conflict and power. Today, Mars continues to intrigue us, not as a harbinger of conflict, but as a potential cradle of life and a future home for humanity. The discovery of water ice and the possibility of liquid water beneath its surface have fueled our imaginations and scientific endeavors. Unlike our own blue planet, Mars appears as a cold, arid desert, its surface scarred by ancient volcanoes and canyons vaster than any on Earth. The largest volcano in the solar system, Olympus Mons, and the Grand Canyon, Valles Marineris, are testaments to the planet's dynamic geological past. But beneath this seemingly barren facade lies a history as rich and complex as our own. The layered rock formations and sedimentary deposits suggest that Mars once had a more hospitable environment, possibly with rivers, lakes, and even oceans. A history that may hold the key to answering one of humanity's most profound questions: are we alone in the universe? The search for microbial life, past or present on Mars, could provide crucial insights into the potential for life elsewhere in the cosmos. Join us as we embark on a journey to unveil the mysteries of Mars, exploring its geological wonders, its potential for life, and the challenges and opportunities it presents for future exploration. From the early flybys and orbiters to the sophisticated rovers and landers, each mission brings us closer to understanding this enigmatic world. From the towering heights of Olympus Mons to the depths of Valles Marineris, Mars promises a tale of discovery, wonder, and the enduring spirit of human curiosity. As we continue to push the boundaries of space exploration, Mars stands as a beacon of hope and a testament to our relentless quest for knowledge. Mars, once a world teeming with volcanic activity, bears the scars of its fiery past. The planet's surface is dotted with ancient volcanoes, their once molten rock now solidified into rugged formations. These volcanic features tell a story of a time when Mars was geologically active, with magma flowing freely and reshaping the landscape. Olympus Mons, the largest volcano in our solar system, stands as a testament to the planet's ancient fury, its summit reaching 3 times the height of Mount Everest. This colossal volcano, with its sprawling base and towering peak, is a reminder of the immense forces that once roiled beneath the Martian surface. The sheer size of Olympus Mons is a marvel, dwarfing any volcanic structure found on Earth. Valles Marineris, a system of canyons so grand it dwarfs Earth's Grand Canyon, stretches across the Martian surface, a testament to the immense tectonic forces that once shaped this planet. This vast canyon system, with its deep chasms and towering cliffs, offers a glimpse into the planet's dynamic geological history. The formation of Valles Marineris likely involved a combination of tectonic activity, erosion, and possibly even ancient water flow, creating a landscape of unparalleled scale and beauty. These geological marvels whisper tales of a time when Mars was a world in flux, its landscape sculpted by molten rock and shifting plates. The textured rocks and formations we see today are the remnants of a once active planet, where volcanic eruptions and tectonic movements were common. Each rock and crevice holds a piece of Mars's history waiting to be uncovered and studied. But perhaps the most intriguing evidence of Mars's past lies in the subtle hints of ancient water. Dried riverbeds with their winding paths and eroded banks suggest that liquid water once flowed across the Martian surface. These ancient channels are a key piece of the puzzle in understanding Mars's climatic history. Vast plains that were once lake beds, now dry and barren, hint at a time when Mars had a much different climate. These ancient lake beds, with their flat surfaces and sedimentary layers, indicate that standing bodies of water once existed on the planet. The presence of these lake beds suggests that Mars may have had a more temperate climate in the past, capable of supporting liquid water for extended periods. And minerals formed in the presence of water all point to a time when Mars may have been a much warmer and wetter world, possibly even harboring oceans. These minerals, found in various locations across the Martian surface, provide chemical evidence of past water activity. The discovery of these water-formed minerals has been crucial in piecing together the history of water on Mars. These tantalizing clues fuel our imagination, painting a picture of a young Mars that might have been a suitable abode for life. The possibility that Mars once had the right conditions to support life is one of the most exciting aspects of planetary science. Imagining a Mars with flowing rivers, lakes, and perhaps even primitive life forms opens up a world of possibilities for future exploration and discovery. A time when the red planet may have been a vibrant blue, its surface dotted with lakes and seas, its atmosphere thick enough to support clouds and rain. This vision of ancient Mars, with its potential for habitability, drives scientists to continue exploring and studying the planet. Each new discovery brings us closer to understanding the true history of Mars and its potential to have once harbored life. The possibility of life on Mars has captivated scientists and the public alike for decades. The discovery of organic molecules, the building blocks of life in Martian soil, has further fueled this fascination. While no definitive evidence of past or present life has been found, the search continues. Rovers like Curiosity and Perseverance scour the Martian surface, drilling into rocks, analyzing soil samples, and searching for signs of ancient life or even extant microbial life hiding beneath the surface. These robotic explorers act as our eyes and hands on Mars, meticulously gathering data and sending it back to Earth, where scientists eagerly analyze every bit of information for clues. The question of whether we are alone in the universe hangs heavy, and Mars, with its tantalizing hints of a potentially habitable past, remains our best bet for finding an answer. The Martian atmosphere, a wispy shroud of gas, presents a stark contrast to Earth's life-sustaining blanket. Composed primarily of carbon dioxide with a thin scattering of other gases, the Martian atmosphere is about 100 times thinner than Earth's. This thin atmosphere provides little protection from the sun's harmful radiation, making the surface of Mars a hostile environment for life as we know it. The lack of a substantial atmosphere also means that Mars cannot retain heat, resulting in extreme temperature swings between day and night. These harsh atmospheric conditions pose significant challenges for future human exploration. Landing safely on Mars requires navigating the thin atmosphere effectively, and surviving on the surface necessitates protection from radiation and the ability to withstand the extreme temperatures. The Martian surface, a desolate expanse of rock, dust, and ice, reflects the planet's harsh realities. Temperatures plummet far below freezing, and the thin atmosphere offers little protection from the sun's relentless radiation or the impact of meteoroids. Dust storms, sometimes spanning the entire planet, can rage for months, blanketing the surface in a reddish haze and posing a significant challenge to future missions. The lack of liquid water on the surface, except for seasonal flows in some regions, further compounds the difficulties of sustaining life. Despite these challenges, the Martian surface holds clues to the planet's past and potential. The presence of polar ice caps, composed mostly of water ice with a layer of carbon dioxide ice on top, suggests a vast reservoir of water that could be crucial for future human exploration. Water, the elixir of life, is not just essential for our survival on Earth, but also holds the secrets to understanding the mysteries of other planets. It holds the key to understanding Mars's past and its potential for harboring life. The presence of water in any form is a significant indicator of the planet's history and its ability to support life. While liquid water is scarce on the surface today, the Martian landscape tells a different story from its past. Evidence suggests that Mars was once a much wetter world, with vast lakes and flowing rivers that shaped its terrain. The presence of ancient riverbeds, lake beds, and other geological features and minerals formed in the presence of water all point to a time when liquid water flowed freely on the Martian surface. This flowing water would have created an environment potentially suitable for life, making Mars a fascinating subject for scientists and researchers. Today, vast reserves of water ice are locked beneath the surface and in the polar ice caps. These ice deposits are crucial for understanding the planet's climate history and its potential for future exploration. The polar ice caps in particular are a focus of study as they contain clues about the planet's climatic changes over millions of years. This water ice represents a valuable resource for future human missions. It could be extracted and purified for drinking water, used to grow crops, and even split into hydrogen and oxygen for rocket fuel and breathable air. The ability to utilize these resources effectively could make long-term human habitation on Mars a reality. Imagine greenhouses filled with crops, sustained by the very water that once flowed on the planet's surface. Through processes like water electrolysis, we can generate hydrogen and oxygen, essential components for rocket fuel and breathable air, making Mars a viable outpost for future space exploration. The presence of water on Mars makes it a prime target for continued exploration. Rovers and landers are constantly studying the Martian surface, searching for signs of past life and understanding the planet's geology. Scientists analyze samples brought back from Mars, looking for organic compounds and other indicators that could reveal whether life ever existed on the red planet. The search for life beyond Earth continues, driven by the tantalizing clues left by water on Mars.